Here we're asked to graph the cubic function by transforming the parent function and make sure to include at least 3 points. So in this one here, the parent function, if it's a cubic, right, is y equals x to the power of 3. If I were to think of my 3 main points when I'm looking at a cubic function, I usually start at the origin. I know that's my turning point for a cubic function, that middle point there. I know that 1, when I plug in 1, it gives me 1, 1. When I plug in negative 1 cubed is just negative 1. So normally, here's the parent function here, is that it looks something like this. It's not perfect, but in general. And what we're going to do is we're going to transform that. So what that means, I'm going to go ahead and switch it up to green here. We're going to take these transformations that I see, and we're going to go see what it looks like. So in this case here, we do not have an a or a b value because there's nothing being multiplied by my cubic function or multiplied by it inside these parentheses. So there's no vertical stretch or horizontal stretch or compression or no flips. So if we look at the h value, if it's subtracting by 3, we're actually going to move, I'm going to start with the turning point here. We're going to move it 3 to the right because it's minus h here. Then I have a k value of plus 2, so it's going to go 3 to the right and then 2 up. So basically, my turning point here is now going to be at 3, 2. There's no stretch or anything like that, so I'm actually taking these points here and I'm also moving them over 3 and up 2. There's no change here, so we're just shifting this whole thing. So what we should see here is that the general cubic function here just looks like this.